jumping joysticks, beat dropping CircuitPythonistas, it's Prof G with a challenge lesson. Now you know how to work with a joystick in CircuitPython. In this lesson, DJ Blinka will ask you to create a joystick interface where the vertical axis will change colors of neopixel lights and the horizontal axis will change the flash speed. We'll start with the code from our joystick lesson that we saved as joystick-pico.py. And as a reminder of how we wired up our joystick in that lesson, power went to 3.3 volt, the x-axis connected to A0, y-axis connected to A1, button connected to GP6, and the ground could go to any ground. And in this lesson, we also want to add a neopixel strip to the build with the signal going to GP15, power to the V-bus, and ground to any ground. Now, as a reminder, here's the code that we created at the end of our joystick lesson, joystick-pico.py. And now my students and I have one change in here. It seems that the cheap AliExpress joysticks that we're using have the X and Y axis incorrectly labeled on the joystick. So I had to switch the X axis to A1 and the Y axis to A0. If you're not using the same cheap joysticks as we are, you probably have these values reversed. So here's your challenge from DJ Blinka. Modify the joystick-pico.py code that you wrote earlier. Remember the X and Y values for those retrieve a value that maxes out at 65,535. Attach your neopixel to GP15. You're going to use the Rainbow IO library's color wheel function to take the joystick's Y-axis reading and map that to a color wheel input from 0 to 255 so that the Y-axis controls color. Now the X-axis is going to control the strobe speed. So all the way to the right, we'll flash the lights on for 0.05 seconds, then off for 0.05 seconds, and move all the way to the left. We'll slow down the flash so it's 0.2 seconds on, 0.2 seconds off. Now pressing the button should toggle lights off or on. Remember, tapping down on the joystick presses the button. Here's a look at what properly functioning code looks like. Up is in red. You can see as I move down, I move all the way through the color wheel until bottom down in red. Now the X-axis controls the flash speed. All the way to the right is the fastest flash. That's at 0.05 seconds on and off each. And all the way to the left is 0.2 seconds on and off. That's the slowest speed that I've got. You can see how things look if I let my joystick center. And if I press my joystick button, you can see that that toggles off and then on. So I can turn my lights off or on. That's it. So once again, here's the challenge. Pause. And then when you're ready, resume, and we'll compare answers. So we're going to add neopixels here. So I'm going to import neopixels and set up my neopixel strip with strip equals neopixel.neopixel, capital N, capital P, passing in board.gp15, and I've got 30 neopixels on my strip. Then below this, I'm going to say strip.fill, and between two sets of parentheses, 0, 0, 0, that's going to turn the lights off at start. And before my while true loop, I'm going to change my print statement so it says DJ lights running. And now I'm going to set my range values because I'm going to need to map from the values on my joystick, which are 0 to 65,535, and the values of the color wheel values that I'm going to pass in, which are 0 to 255, and the value for my flash duration, which I eventually want to be between 0.2 and 0.05. Now this is how I'm going to do it. First, I'll set a constant max underscore color underscore value, and that should equal 255. That's the maximum color value I'm going to pass into the color wheel function. Which reminds me, I got to go up here and from Rainbow IO import color wheel. And I'm going to add more range values, max underscore joystick underscore value. Remember, this equals 65,535, same as a potentiometer. And then I'm going to say max flash duration equals 0.15. Now this is really going to be 0.2, but I'm going to add 0.05. I should have said 0.05 instead of 0.5 as the minimum flash duration for this range. So down below, I'm going to say min underscore flash underscore duration, and this equals 0.05. I need to have some flash duration in there, otherwise it's going to look like my lights are solid. Then after I get my X value and my Y value, I'm going to add a new line where I calculate my color, and that's going to be equal to Y underscore value times max color value divided by max joystick value. I don't need parens around the division section, but I'll put them in there because I think it makes it easier to read. I don't need them. Now I should set this to an integer. I don't know if the color wheel requires an integer, but it doesn't hurt to do this. So I'll put parens around this whole equation and put lowercase I and t in front. That's just going to drop any decimal points. And next I'll calculate my flash duration. the calculation is going to be pretty similar to the calculation I did above. So I'm just going to copy everything inside of the int here. Now remember, I don't want my flash duration to be an integer because I need this to be decimal points. It's going to be between 0.2 and 0.05. But in flash duration, I'm going to check the x value, not the y value. And I'm going to grab the max flash duration. I'll use that instead of the max color value. But there's one more thing I want to do. I want to reverse the direction of the flash. I want my largest flash value to be when I push the joystick to the left. That's going to be when I have my 0 value. And my smallest duration should be when I push my joystick to the right. That's when I've got my full maximum 65,535 joystick value. So I'm going to copy my max joystick value, put parens around my x value, and say max joystick value minus x value. That's just going to flip my range. Everything else is going to work perfectly. Then I'll put parens around this whole equation here, and I'm going to add my minimum flash duration to the end. Without this, my range would be between 0.15 and 0, but by adding the minimum flash duration, which is 0.05, my flash duration now goes from 0.2 to 0.05. Now I don't need this while statement or the time sleep, so I'm going to delete this. And just above the print statement, let's get our colors and turn them on and off so that we get a flash. So above print, I'm going to say strip.fill, passing in the colorwheel function, calling the color. Remember, colorwheel takes a number between 0 and 255 and returns a real color through subtle changes of the rainbow. Then below this, I'll say time.sleep, passing in flash underscore duration. Then strip.fill, passing in between two sets of parentheses, 0, 0, 0. That's going to turn all my lights off. And I'll time.sleep, passing in flash duration again. Then let's add the code to turn our lights on or off. And to do this, we're going to toggle our brightness. So I'm going to say if button.value double equals false, colon. This means the external button has been pressed. And indented below this, we'll say strip.brightness equals 1 minus strip.brightness. That simply toggles the brightness between 0 and 1. Then I'll modify my print statement, putting parentheses around the x and y value. Then I'll say comma color, printing out the color, comma flash duration, printing out the flash duration, and comma brightness, printing out the brightness. Now I ran this and everything worked perfectly except for the button press. The button press wasn't working reliably, and I know what the problem was. I needed to debounce the button. You see, without the debouncing of the button, I can rapidly flip between on and off. So that means if I press down on an on, it might turn off and then on again by the time I release it, and it doesn't look like the lights have been turned off. Well, in an earlier lesson, we learned how to debounce buttons so that it only records one press at a time. And remember, we've got information on debouncing buttons in our CircuitPython school tip sheet. So let's search for debounce. And it looks like I'm in the section for debounce buttons for the CPB, but I'll just make the changes that I need for the Pico. First, I want to import the adafruit debouncer button function. Copy this. Head back to our code and paste it in by our import statements. Then I'll copy these 3 lines of debounced code. Head back over to PyCharm. And let me paste this in underneath our 2 lines where we set up our button initially. And we still need these 2 lines of button setup, but I'm going to change the name of the button object we create here to button underscore input. I'll use that on our second line as well. Notice the comment in the switch to input line says pull up for external button, and we already have our pull up resistor, so we're going to delete these 2 lines. We don't need them. But this comment down here says false for external buttons. So instead of saying value when pressed equals true, we're going to change that to false. And we'll make sure the button object that we create on this third line here is called button, not button A. And in the button function, we want to pass in button underscore input, the object we created in the lines above. Cool. Debounced object created. And now remember, in our while true loop, each time we check our button value, we need to make sure that we call button.update, open and close parens. That makes sure that we get the correct current status of our button. And if we look over at our tip sheet to check to see if a button is pressed, well, we just say if button.pressed. So I'm going to copy this line, head back to our code, and paste it over the old if statement that I have here. Our button is called simply button, not button underscore A, so change that. But this should work fine. Let's get into the terminal, launch PyCharm, save our code, and take a look at the magnificence. Open the terminal, save, and we're flashing. Let me pick this up and move the joystick up. We can see we're turning toward red. Move down, we're moving through the rainbow as we move the y-axis. To the right speeds things up and down to the right changes colors while we're flashing fast. Drag to the left, we slow things down. This is looking great, and we can see how things rest in the middle. And I'll press my button. I gotta get a good press, and the lights turn off. The button isn't super reliable, but press again, the lights go on. Again, off, on. So the toggle is working great. The joystick is working great. Left, right, X value changes the flash. Up, down changes the color. So you can fool around with this, but I think right now we should save this to our CircuitPython school folder. Let's make sure it's saved as joystick djlights.py. Close that outermost tab. And Pythonista, I hope you got the challenge correct. If not, hopefully you understand things. If you need to rewatch that lesson, feel free. But now you're ready to add lights to any DJ sesh, throwing down skills as you sling fat beats. Be sure to come back and be sure to make something awesome.